Okay, so first example here, I've got the shorthand here just to remind us. So if we've got f of x equals 2x squared, what will f dashed x be? Well, f dashed x will be equal to 2 times by the power 2 times 2 x, decrease that power by 1 is 1. So our final answer is 4x. What about for this one? So for this one we have f of x equals 2x cubed. So f dash x will be equal to 2 times 3 x to the power of 3 minus 1. So equals 6x squared. Okay, and moving on to some more examples. So what about this one? We have 5x. So f of x, another way of writing this is 5x to the power of 1. So f dash x is equal to 5 times 1 x to the power of 1 minus 1. So you should know that anything to the power of 0 is 1. So this becomes 5 times x to the power of 0 equal to 5 times 1 just equal to 5. But what about this one here? So we've got a square root. So we have f of x equals square root of x. So another way of writing the square root is to put it as x to the power of 1 over 2. So what if we want to differentiate this? So we have f dash x times by that power equals 1 over 2 times x and a half minus 1. So this would actually go to minus a half. So this becomes 1 over 2 1 over 2 x to the negative 1 over 2. And on that, gone. What about these examples here, where the x term isn't on the top of the division line? So my kind of rule of thumb is you want to get it into the way that's easiest to understand it. So don't differentiate straight away. Put f of x in a form that's easy to differentiate. So f of x is equal to, well, when x squared and something's on the bottom, this is the same as it being on the top. So you have minus 2. So now this is a lot easier to differentiate. So you have f dash x is equal to times by the power, so that's minus 2 x. I need to decrease the power. This can trip people up sometimes. Remember, this is a minus, so that's going to go from minus 2 to minus 3. And that would be your final answer. Now you could rewrite this in another form if you wanted. We could go minus 2 all over x cubed. And that would be your final answer. All right, this one over here. This one's, you can already see it looks a bit more complicated, but actually it's not too bad to tackle if you just break it down into its pieces. So we'll start off by rewriting f of x in a form that we like more. So we go f of x is equal to, we'll take out the 1 over 10, because that's 1 over 10. And then we'll move the this x term from the bottom up to the top half, so it's easier to multiply by. So times by x to the power of minus 5 over 4. All right, and now we can start to multiply by through. So we're going to times by this power, then we're going to decrease it by 1. Equals 1 over 10 times minus 5 over 4 times x to the power of minus 5 over 4 minus 1, which is the same as 4 over 4. So what does that equal? So we've got minus 5, 1 times minus 5, over 10 times 4, which is 40. And then this is times by x to the power of minus 5 minus 4 is just minus 9 over 4. Okay, so let's try and simplify this down a bit. So 5 over 40 is the same as 1 over 8. So, like I said, minus 5 over 4. You could flip this around and go 4 divided by 5. 40 divided by 5 is 8. So 5 over 40 must be 1 over 8. So that's negative 1 over 8. And this can be simplified as well. So you have your x to the power of 9 and your over 4. So, and this is negative. So we can actually rewrite this again on the 1 over. So you go 1 over 9 to the power of 4. And we can rewrite this as one number. So if we just go 1, so the final answer is 1 over negative 1 actually over 8 to the power of x 9 over 4. That is our final derivative. So you can see there's quite a few more steps, but the idea is behind it. This is all just kind of maths, kind of simple maths, multiplication, division, so it shouldn't be too much of a problem.